Hi, my name is Safa Akila binti Siddiq. My metric number is 107095. In the experiment, we want to identify the angles and the roundness. So the objective of the experiment is to examine angularity of angle gauge block and sine bar application. Second is to observe the height of the gauge block stack h and the sine of desired angle, which is theta. They perform the eccentricity and the measurement using a test indicator. Without further ado, we go to the introduction. In this case, we have a two measuring, which is angle and roundness. So the first is measure angle. Sine bar is a rectangle section bar with two finished rollers and equal diameter. One on each of the bars. Its sine bar is made of a high carbon, high chromium corrosion resistant alloy. It's hardened and balanced, and it used to measure and weigh precise angles. The sine bar theorem is based on two cylinders and their width form a right angle hypotenuse. The opposite of the right triangle is formed by the specific gauge block stacked under one end of the sine bar. When the right products are combined in the right way, the bar surface is exactly inclined at the chosen angle. So in determining the angle of the size of desired angle, I have two methods, which is a method 1 and method 2. Method 1 is a sine bar method, and method 2 is a dimensional method. So we go through for the second measuring roundness. It enables to see rotating mechanical elements that are not well aligned with the imaginary line of the rotation axis. See, revolving mechanical devices are imprecise. The situation is classified as run out or literally run out. We will see a good example of a run out incident during the drilling operation. Sometimes drillers have a difficulty obtaining an accurate diameter of the drilled object, in which run out can result in a large hole than expected. Okay, so for the engineering, we have a two of run out, which is axial run out and radial run out. However, work caused by inefficient lubricant may result in an extreme run out, which can be a complicated combination of both radial and axial run out. That's all for me. I will pass to the next presenter.
So for the material and apparatus for the measuring the angle of this experiment is, so first, this is the back of linear gauge block. This is the vernier caliper. This is dial gauge. This is sine bar, and this is angle gauge block.
So today I am going to demonstrate on how to do the experiment 8, which is angular measurement by sine bar method. So first of all, this is the gauge block. So first we must measure each of the side of the gauge block. So for example, this is X, this is Y, and this is Z. So to measure this length, we use the vernier caliper.
This is the X, and this is Y, and this is Z.
So next, to handle this experiment, we must align this gauge block right here. You can see right here. So it's basically this. So the purpose of this experiment is we take any two or more block stack under this gauge block, and the purpose is to make sure that when we move this apparatus, the needle will not rotate. So for example, if we use this two stack, you can see the movement of the needle, right? So we must find the perfect combination of two or more block stack in order to make the needle did not rotate. We try 21.5 mm plus 1.17 mm. So as you can see over here, the needle is not moving right. So this is basically the right step to ensure that the needle is not rotating. So the height that we can conclude is the 21.5 millimeter plus by 1.175.
Assalamualaikum. I am from group 1F. Today I'm gonna demonstrate the experiment run out gauge system. So first to do the experiment, the objective of the experiment is to perform the eccentricity measurement using the test indicator. So as you can see, we have the equipment we'll be using is first is this cylindrical workpiece that we will be measuring the eccentricity, and this is ROG 221SS model of run out system gauge that we'll be using to calculate to measure the roundness. So to measure the roundness, we will put the cylindrical workpiece at this equipment, and we need to measure at the top, the middle, and also the bottom part. So we need to put the needle of this measurement device at top of the cylindrical device, and then we set it to 0. We press the set, and then it will be set to 0. And after that, okay, to measure, we need to rotate and find the maximum value and minimum value, which we will get what minimum value of negative and maximum value. Then we find it 3 values and get the average. After that, we repeat the same procedure at the middle, and also we need to switch up and calculate at the bottom for 3 times, and then find the average. That's all.
Thank you.
Okay, hi, my name is Sharon. My number is 198590. So we'll jump to the result of the experiment. So the first for the experiment 8, we do 2 experiments. So for the first experiment is measuring angle. As we can see, we have 6 combination of the linear gauge blocks, and we have to find the height and the flatness. So from these 6 combination, we get the average of 22.685 height mm, and we get the plus 0.6 mm in flatness. So from this table, we can see that the dimension of gauge block using vernier caliper. So we have 3 dimensions that we have to acquire. So X, Y, Z. So for the length of the X, Y, Z, we get 3 times the reading, and we get the average. So for the X, we get 30.18. For the Y, we get 75.41, and the Z, we get 12.94. So from this result that we obtain, we want to find the angle of tilt. So we can use this formula, sin theta equal to X minus Z over Y. So we get the answer at 13.22 degree. So to find the theoretical height, when using sine bar, we can use the formula H equal to 100 times by sine of the angle of tilt, 13.22, and we get the value of 22.87 mm. So for the second experiment, the measuring roundness. So we have to acquire dimension from the cylindrical workpiece at the bottom, middle, and the top. So we get the 3 values for the maximum and 3 values for the minimum, and we get the average. So for the maximum, the average for bottom is 0.091, average for middle is 0.07, and the top is 0.067. So for the minimum, the average for bottom is negative 0.072, middle negative 0.03, and top is 0.028. So that's all from me. Thank you.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Muhammad Samir Saleh Al Akrabi and my matic number is 199948. So my part in this is discussion and conclusion. So in discussion for measuring angles based on the results obtained in table 5.11 as shown here, 6 values of trial and error methods have been used in order to obtain 0 mm flatness. The theoretical value of height of the sine bar is 22.87 mm with an angle of 13.22. The first combination of linear gauge block 22.70 mm, 14.5 mm plus 7 mm plus 1.2 mm, which gave the flatness of plus 2 mm. Then the experiment was proceeded until the combination that gave the total height of 22.67 mm are found, which were from the combination of 6.5 mm and 11.7 mm plus 15 mm and 21.5 and plus 1.17. This combination resulted in 0 mm flatness, which was the objective of this experiment. But based on the theoretical value of the height of the sine bar, which is 22.87, it was slightly different from the experimental value, which was 22.67. The percentage error between the theoretical value and experimental value was 0.875%, which can concluded that this experiment was successful as the percentage error is low. The main cause of the percentage error was probably due the condition of the equipment, since the equipment was quite old. The flaws, especially the rust, the rust can affect the height of the sine bar. Other than that, the vernier caliper that had been used to measure the sine bar may not be in the perfect condition, so the reading shown on the measuring instrument must be affected also. For measuring roundness based on table 5.21, this one, wait, table 5.21, yeah, this one. Based on the table 5.21, the bottom of the cylindrical workpiece had an average maximum eccentricity of 0.091 millimeter and average minimum eccentricity of minus 0.072 millimeter, which while the middle part of cylindrical workpiece had an average maximum eccentricity of 0.7070 millimeter and average minimum eccentricity of minus 0.030 millimeter. Lastly, at the top part of the cylindrical workpiece had an average maximum eccentricity of 0.067 millimeter and average minimum eccentricity of minus 0.028 millimeter. It can be concluded that the different position of the cylindrical workpiece gave a different maximum and maximum eccentricity. This was probably due to the presence of cavities around the cylindrical that had occurred during the machine's process. As a conclusion, to conclude, uh, as a conclusion, based on the results obtained, it can be concluded that this experiment is successful because the percentage of error between theoretical value and experiment is low, which is 0.75%, as stated in the discussion section. The experiment was done within the boundaries with the capabilities given. The study of the application of sine bar and angle gauge block for angularity inspection was achieved. The height of gauge block stack H and the size of the desired angle theta was also found. This was my part, and thank you very much.